Hello, this is Mrs. Akers. This is Algebra 1. This is the week of April 20th. This will be video 1. This video is going to be very heavy on definitions. They are definitions we've went over in the past, but I want to review them and make sure we know them. Okay, so this is from video 1. Again, I would like for you to take notes. We are going to start off talking about a relation. So definition 1. A relation is a set of ordered pairs So a relation can be represented by a table, a graph, a list of the x's and the y's. Can be represented by a mapping, okay, those are all different ways we can show you what a relation is. Okay, so an example of a relation let's say I have homeroom I have the number of students and I have the number of donated canned food for a food drive. Okay, we've done this before. We have homeroom number 1, number 2, number 3, number 4, number 5, and number 6. Homeroom number 1 has 25 students and they have donated 133 cans. Homeroom number 2 has 22 students. They have donated 216 cans. Homeroom number 3 is 24 students and they have donated 148 cans. Homeroom number 4, 22 students and they have donated 195 cans. Homeroom number 5 has 20 students with 74 donated cans, and homeroom number 6 is 21 students with 150 cans. So this table is an example of a relation. Another way I could write is ordered pairs. We've got 25 students in homeroom 1 with 133 cans. We have 22 students with 216. We have 24 that's donated 148. We have 22 that have donated 195. We have 20 that's donated 74. And we have 21 that's donated 150. So this is the relation written as a set of ordered pairs while this up here was the relation written in a table. I could graph these on a coordinate plane. going to go by 50. 50, 100, 150, 200, 250. These are cans. And then students, 5, 10, 15, 20, 25, 30. These are students. 25 students and 133 cans would be here. 22 students and 216 cans be up here. 24 students and 148 cans. 22 and 195. 20 and 74. And 21 and 150. So this is the graph of the relation. Then a mapping is where you take your x's and you list them from least to greatest, and you only do each number once. So I have 22. Oh, nope, sorry. 22 is not my least, and I knew that. I have 20, 21, 22, 24, and 25. My y's from least to greatest, I have 74, 133, 148, 150, 195, and 216. 20 is mapped to 74. 21 is mapped to 150. 22 is mapped to 216. And 22 is also mapped to 195. So there's two arrows coming from 22. Um, 24 is mapped to 148, and 25 is mapped to, 22, I did 22, I'm sorry. 25 is mapped to 133. So this is called a mapping of the relation. Okay, so those are ways that we can arrange a relation or display a relation or say what the relation is. And let's go into definition number 2. The domain. The domain of the relation are the independent values, also called the x values or the first coordinates. So in my example, in my previous example, (20, 21, 22, 24, and 25 are the domain values. Sorry. Alright, Definition 3. Range of a relation. Are the dependent values also known as the y values or the second coordinates. So in the previous example, $74, $133, $148, $150, $195, and $216 are the range values. Notice, in the domain values, I only wrote down 5. 1, 2, 3, 4, 5, because 22 repeated. When I'm stating the domain or the range, I do not repeat values. I write them in order from least to greatest, and I do not repeat. Since I did not have any repeating range values or y values, I have 6 in the range. Now, an important concept that you will be asked about on various occasions is the relation a function? Is the relation a function? Functions are a special type of relation. To be a function. To be a function. Each member of the domain must be paired with exactly one member of the range. Okay, another way to say it. Each x must be paired with only one y. The statement does not work in reverse. Okay, it's only forward. Each x must be paired with only one y. So when we look at our example before, our previous example, we have an x value of 22 paired with, what's it paired with? It's paired with 195, sorry, 195 and 216. So since the x value or domain value of 22 has two y values or range values, the relation is not a function. Okay. So let's look at some examples. Determine if each relation is a function. If not, explain. Alright, so example 1. We have the relation of 0, 1, 1, 2, 1, 3, 2, 4. Some of you can look at the ordered pairs and tell me the answer. Some of you cannot. My opinion, one of the easiest ways to tell if a list of ordered pairs is a function is to make a mapping. Okay, so first thing I'm going to do is make a mapping. You're going to have your x values listed from least to greatest, only written once, 0, 1, and 2. Your y values written from least to greatest, 1, 2, 3, 4, written only once. So in the mapping, remember, do not repeat an x or y value in the column. Okay, now we draw a line. 0 maps to 1, 1 maps to 2, 1 maps to 3, 2 maps to 4. Now I look at how many arrows come from each x. I see the x equaling 1 has 2 arrows coming from it. So this is not a function. Why? Because the domain value of 1 is mapped or paired with more than one range value. Okay. Example 2. We have 0, 1. We have 1, 2. We have 2, 2. And we have 3, 4. Again, let's first make our mapping. We're going to have our x values, our y values. We have 0, 1, 2, 3. We have 1, 2, 3. No, not 3. 1, 2, 4. 0 maps to 1, 1 maps to 2, 2 maps to 2, 3 maps to 2. look at how many arrows come from each x. Each x has exactly one arrow coming from it. So this is a function. I do not care how many elements are mapped to each y. I only care about how many elements each x are mapped to. Okay, so make sure you keep that straight. Alright, I think that's enough for today. So take your time to digest the difference between a function and not a function. Remember, it's a relation if you have an x and a y. If you have x and a y, it's called a relation no matter what. There's a special kind of a relation called a function. A function occurs if each member of the domain is mapped with exactly one member of the range. We can check that by looking at a mapping. I'm going to show you in the next video how to check it using a graph. But until next time, please answer the questions in Google Classroom about this video to show that you have watched it. Thank you and have a good day.